We're going to only graph y equals a sine of x and y equals a cosine of x from this equation here, this one here. So basically we're just doing this portion, and this is called the amplitude. And I want you to know basically what the amplitude really is. You already know that sine of theta equals y over r, or some of you all know this is as opposite over hypotenuse, and cosine you know as adjacent over hypotenuse. Okay, I'm using this because it's based on the unit circle, and what I'm going to do is cross multiply here. So when I cross multiply here, I'll put these in fraction form, and I move up the r, I get r sine of theta equals y, and I get r cosine of theta equals x. So basically, your radius here is your amplitude. That's all it is. It's whatever the radius was. So I'm going to take away the radius here and call this the amplitude. In this case, we're calling it A. So if I look at this circle I tried to draw, these three circles I tried to draw, I'm going to call this red one here a circle with radius 1/2. So the red circle is the radius is 1/2. That means the amplitude is 1/2. And I'm going to call, that's not a minus sign, that's supposed to be a key. So I'll just make it a dot here. Alright, the black one's going to be my parent function with the radius of 1, which actually equals our amplitude. And the green one, I'm going to call my radius. So the green one, the radius equals 2. The black one, let's see, the radius is 2. Let me draw it closer. The black circle is going to be the radius is 1. And the red one, I'll try to squeeze it in here, is the radius is 1/2. That's your radius. So the green one's going to be r equals your amplitude, or 2 equals your amplitude. Okay, we're going to graph these quickly. I assume that you already know how to graph the parent functions of these, and I'm going to graph sine and cosine. Here we go. Now what I'm going to do is do like I did in the last video, and for sine, I'm going to draw the parent function. So I'm going to let 1 be about here, so that's up 4, and -1 here. And all I'm going to do is draw dots. Then I'm going to fill in my quadrantal radians. So dot, I'll go down 3, dot, 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 dot. That's what I say. Then I draw a curve. And at that point, I fill in my radians. You can do it that way. It's not as precise, but it helps sometimes when you're just sketching the graph. Alright, and you continue it on the other side. I'm just going to do this side right now, the positive. Now, this one was y equals sine of x. That means my radius is 1. Now I'm going to do the smaller one. So I'm going to make this 1/2 and this -1/2. I'm still going to start at 0, and recall for the parent function, some black, you have your x values here, your radians of 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we had 0, 1, 0, 1, 0. So all you're going to do for this next one is multiply everything by 1/2. So you're still going to get 0, but 1/2, 0, 1/2, and 0. Okay, just make sure you know this for sine. It's 0, 1, 0, 1, 0. Remember that pattern, and the rest will be easy. So I'm just going to do dots here. Dot, 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 dot. And I'm going to graph this. This would be like a compression, a vertical compression. Is the same thing as the amplitude, but we're kind of magnifying it or making it smaller. Okay, now for so this one was y equals 1/2 sine of x. Now for the larger one, we're going to go up to 2 and then -2. And I'm just going to do it again. I'm going to dot, dot. I'm just sketching this. And I knew I'd run into this down here. All right. And then I'm going to see I'm amplituding it. I still go through my same zeros. But my amplitude, this was a vertical stretch. You're stretching it like a rubber band. And that is what amplitude is. And you can continue this on. I don't know if I want to do that. Let's go ahead and do that. So this can be dot. Where's 1? -1. Dot, 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 dot. And continue that on for sine. And that was awful. But I'm just sketching it. So here we go. Something like that. Then the red one would go to 1/2. So I put dot, 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 dot. And just make it 1/2. The green one's going to be dot, 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 dot. And I'm sorry this side's not very good, but I'm just sketching it. So, something like that. Just look on this, the right side. Okay, now we're going to do cosine the same way. Cosine, just remember the values. Let's see if I can put it kind of in the middle here. Remember that starts with 1, 0, 1, 0, 1. So your other values, this is your y here. So when we do the 1/2, it's just going to be 1/2, 0, 1/2, 0, 1/2. And this would be the 1/2 cosine. And I can't squeeze all that in, but that's cosine. And then we're going to do 2 cosine of x, which would just be 2, 0, 2, 0, 2. And then you know your radians that go here. Okay, so we're going to draw, I probably have to erase some of this, but I'm going to let do my parent function first. That's 1, -1. I'm just going to do dot. You're making a V. Dot, 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 and yeah, I'm going to erase this, so y'all get the idea. Dot, dot, and make the curve. All right, for the 1/2, I start at the same. I go through the same zeros, but I only go to 1/2 here. And we stopped here, so stop about here. So this is a kind of like a compression. And then for the 2, 1, the amplitude of 2, start here, go through our zeros again, and this is the stretch or the amplitude. And it looks like a V when you put the dots, but then you make it curvy. And I'm not even going to try to do the other side. The other side would continue on because it's a continuous wave. Okay, the next video we're going to do is this new center line, and it'll be of the form y equals sine of x plus d. This, you could say plus or minus because we'll shift up and down, and we'll also do cosine of x plus or minus d.